In this section, we're going to focus on the circle of curvature, or the circle which best approximates a curve at a point. In order to do so, we're going to start by just looking at an abstract idea, where we have a curve, path of some particle as it flies through space. We're going to pick a point on that curve, and then we're going to draw a vector from the origin to that point. That right there is the position vector, or r of t. At the point, I can also calculate the derivative, giving me the velocity. That could be really long, or it could be really short, depending on the speed. If I make the speed 1, or take this vector and make it a unit vector, then I get what's called the unit tangent vector. The principal normal vector, the unit normal vector, is a vector of length 1 that points orthogonal to the curve in the direction in which you're turning. At this point, I can create a circle which in some sense approximates the curve. That circle has a radius, and the radius of that circle, in this case, it's about 1, it's a little more than 2. We'll just say the radius is approximately 2. The radius, represented by rho, if it's 2, then the curvature, which is 1 over the radius, is, in this case, 1/2. If the curvature is 1/2, then the curvature vector, which is the rate of change of the tangent vector with respect to length, the tangent vector is changing slowly as we go along. It changes by about 1/2 unit. So we're going to create a vector that's 1/2 as long, and this vector right here is our curvature vector. Recall the way to calculate that is to find the derivative of t with respect to t and then divide ds by dt, which is t prime over speed. Now, if I want to get the center of curvature, that point right there in the middle, the way to get the center is I'm going to use vector addition. I need to take this vector and add it to that vector, giving me a vector which ends at the center. So this first vector was r. The second vector is a vector whose direction is n. That's the direction, and the length of that vector is the radius of the circle. So if I take r and add rho times n, that gives me my center of curvature. What we're going to do now is we're going to look at this with a specific example. The curve we're going to focus on is a helix, cosine t, sine t, t. Here is a picture of what that's going to look like. We're now in 3D, and we want to find the center of curvature. How do we find this point in space where the center of curvature is? I'm going to have to start from the origin, which is somewhere down here, find an equation to that, or a vector to that point, and then find that vector right there. And we're going to do that now using this curve. So in order to do that, I need to get rho, which means I need to get the curvature. So to get the curvature, I need to find r prime, which is negative sine t, cosine t1. The length of that vector is the square root of sine squared plus cosine squared plus 1. That's 1 plus 1, so that's root 2. Which means the unit tangent vector is 1 over root 2. It's this vector over that. I'm going to leave the 1 over root 2 out front so that I can simplify and not have to write it as much. If I find t prime, which is what I need up here in order to get the curvature, then the constant is just a constant. The derivative of negative sine gives me a negative cosine, negative sine, 0. The curvature is t prime over the speed. So take this vector and divide it by the speed. So if I divide by the speed was a root 2. That means I have a root 2 in the bottom and another root 2 in the bottom, giving me 1/2. Negative cosine t, negative sine t, 0. At this point, if I want to find the curvature, that's the length of the curvature vector. And here, I just need to take 1/2 times the length of this vector. Well, that's 1/2, and the length of that vector is a cosine squared plus sine squared plus 0. Well, that's just 1. So the length of that vector is 1/2, which means the radius is 2. a reciprocal of that. Now, let's find it at, I guess right now I need to give you a time point. This is when t is pi halves. So, at pi halves, I need to find out what r is. Well, r of pi halves, just put pi halves in. That's 0, 1 pi halves. I need the rho at pi halves. Well, rho is always 2. And I need n at pi halves. Wait a minute, have I gotten n yet? I haven't. How do you get n? N is the curvature vector over the length of the curvature vector. So I need to take this vector right here and divide it by a half. So if I take this vector and divide it by a half, notice that the halves cancel. And so n is found simply as negative cosine t, negative sine t, 0. If I put in a pi halves, that gives me a 0, negative 1, 0. Which means the center is my r, 0, 1 pi halves, plus 2 times 0, negative 1, 0, which is precisely 0, negative 1 pi halves. And that puts us at, essentially, here's our 0, move 1 left, and then go up pi halves. And that's where we're at. That completes this web.